Now we take some examples to demonstrate how we can find the most powerful test. So first example, let x1, x2 up to xn be the random samples from the normal distribution with mean 0 and variance sigma square. We are interested to test the hypothesis, that is h naught sigma square is equal to sigma square naught, against the alternative hypothesis sigma square is equal to sigma 1 square. As sigma naught square is not equal to sigma 1 square, so h1 could be sigma 1 square is greater than sigma naught square. Find the most powerful test for size alpha. So let's see how we proceed for this one. Similarly, first of all, we have to write down the maximum likelihood under the null and alternative hypothesis. So let's say under the null hypothesis, I just write down L naught, and that is our distribution is normal, so that is 2 pi sigma naught raised to power, if we write down sigma square, then it is n over 2 into e raised to power minus 1 by 2 sigma naught square into sum xi square. Similarly, the likelihood function under the alternative hypothesis, that is L1, and that is equal to 1 over 2 pi sigma 1 square, that is raised to power n by 2, and e raised to power minus 1 by 2 sigma 1 square sum xi square, where xi basically belong to the real line and it varies, I varies from 1 to n. Now according to the Neyman-Pearson's lemma, reject h naught if L1 over L naught is greater than or equal to k. So where k is the positive number and it is determined by the size conditions. So using this condition, so we have just write down this one, that is sigma 1, I just take the square, it is going to cancel out, and that is sigma 1 under root 2 pi raised to power n over sigma naught under root 2 pi raised to power n and into e raised to power minus 1 by 2 into 1 over sigma naught square minus 1 over sigma 1 square, and we are going to take some xi square as a common, and it should be greater than or equal to k. Now taking the log on both sides and merging these constants to k, we get, that is actually that is positive, because when we are going to take the ratio, so ये जब हमारे पास L1 जो है ये नेगेटिव हो जाएगा और ये हमारे पास पॉजिटिव हो जाएगा. So that is 1 over sigma naught square. So this is equal to now, that is 1 over 2 1 over sigma naught square minus 1 over sigma 1 square into sum xi square greater than or equal to, we are going to merge these constant into k, let's say we call it c, and further these are also constants, so we are going to merge these also in c. So this is basically sum xi square greater than or equal to, let's say I call it c1. Now next step is that to find the c1. To find c1, we need to use the size conditions that is, what are the size conditions? That actually the probability of type 1 error which is equal to alpha. And what is the probability of type 1 error? That is actually the reject H naught when it is true. So that is actually alpha. So we apply this one, that is probability sum xi square is greater than or equal to C1, and that is actually equal to alpha when sigma square is equal to sigma naught square under the null hypothesis. In other words, under the H naught. We need to find the distribution of some xi so that we can find this probability. We need to find the distribution of some xi square. So how we proceed that? Now we first consider the original xi's. First consider the original xi's which is given in the question, that is xi basically the normal with mean 0 and variance 1, or we can further write on it as, let's say, yi, that is xi over sigma naught. We just assume that this is also a normal with mean 0 and variance 1, as yi's are independent. So some yi square, basically if we take the square of this one, so the sum yi square basically that is equal to the chi square with n degree of freedom. We have already known this result. So hence test is reject H naught if some xi square over sigma naught square is greater than or equal to k. So basically the probability of it means that the probability of some xi square over sigma naught square greater than or equal to k is equal to alpha. Basically this is the situation. So the most powerful test for testing hypothesis, that is sigma square is equal to sigma square naught versus the alternative that sigma square is equal to sigma 1 square at alpha level, that is reject H naught if some xi square over sigma square greater than or equal to chi square n into for alpha level. So basically you can see that that is some sort of chi square distribution, and here is your the value of chi square with n and alpha, and that is here your alpha, and this is line basically that is C. So this situation we reject H naught if this situation holds, otherwise accept H naught. So this is basically the best most powerful test if this condition is hold.